by either applying a constant or light, right? But go on. Just because we don't apply a constant and just because we don't apply light, just because we don't apply a wave function, doesn't mean it's wrong. It just means that I like to do a little bit more math than you.
Was kind of almost there, but ultimately he was wrong. Is that the same approach we need to take of something like general relativity as well?
It is, but I would caution to see it in that historical context that you've just made reference to, because it's a little strong to say that Newton was wrong. I would say that any physical theory that we ever write down is meant to describe the universe in a certain domain.
Mm-hmm.
Right. So, like, if we have this function, right, regardless of the interpreting of the function, we now have a system in which, regardless, we have to go back here, right? And we have to apply a rule. Now, what is that rule? Well, the rule is, because of the speed of light, that we have to assume that this equals fucking F equals ma, blah, 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 blah. Right? And, like, from that system, hang on, my recording screwed up. And now from that system, right, when we apply force, right, we still have a system, right? So that system is equals to, right?
And when we gain better equipment and when we make progress, we try to extend the domain of applicability of our understanding. And when we do that, we almost always find that the ideas from the earlier generation, yes, they really work in the original domain, but when you go beyond that domain, you need to update them. You need to replace them. And so Newton did a wonderful job at describing the orbits of the planets. General relativity comes along and says, well, actually, if you go a little bit further than just the orbits of planets, if you want to understand more extreme environments like black holes, then you need these new ideas of the general theory of relativity. And that is indeed the process that we feel we're likely recapitulating now. Because when you try to put quantum mechanics and general relativity together, you do find, at least in the string theoretic context, that general relativity has to yield to additional terms, additional mathematical constructs that Einstein himself did not write down. And so, yes, as we